Everyone, in this video we will be looking into how we can build a RAG system, retrieval augmented generative system, such that the data doesn't leave your computer. Whatever we'll be doing will be done in your machine. The text won't leave your computer. That's what we are trying to achieve here, right? So there are already APIs, right? The cloud APIs are there which can give response, but in that case your data, your context, your query, everything, it goes to the API server provided by different providers like OpenAI, etc. But here you can be assured that your data won't leave your system. Now to prove it, I have kept my internet off, that you can see here. Okay, so I will link this code to in my description, so you can have a look into the code. I'll describe in brief what we are trying to achieve here, how we are doing it. So first is the text file that we are having here. Whatever data that you want to query from will be in your file.txt. Here is the file that I have. It is in the same directory where I have this rag.py is the main file that contains your code. So first we will take in the query. So what is the query that we want to execute? Okay, next we have this function read text file, which text as input the text file, and then it reads the entire text. Second, what we do is split the text. I have described, I've written a custom logic how to split the text, but you can use any of the ready-made functions. Like we have this recursive character text splitter, and this is from LangChain, so you can use that one. Here it is from LangChain text splitter, which gives a more optimal result, but you can define your own splitter. Next, we'll create the vector store from the chunks that we have received after splitting, and it returns the collection and the embedder. The collection contains the entire list of chunks that are there in the vector store, and the embedder, it contains the embedding logic, right? And I pass it to the query vector store, and this query vector store, what it does, it encodes the query and then finds a relevant symmetric, it does a symmetric search across the entire collection and gives the k most, so k equals to 3, so the top 3 results that are most relevant, right, that is returned by this query vector store. And finally the context, that's the context, right, that is returned. The context and the query is sent to this function get Mistral answer, where it queries this. We are using this Ollama. Ollama is used to query from a model. So the model that we are using here is Mistral model. It is about 4 GB in size, and the prompt goes in, and finally we get the response, right? That's the flow. I can show you a demo. I'll just go ahead and run it. So it says enter your questions about the text. I'll ask a question like what is the document about? I'll hit enter and wait for some time. The model runs in the computer, and you can check it. The memory that I have currently is a 8 GB RAM, and it quickly uses up the RAM. Yeah. RAM usage has started to increase. Your machine might get stuck a little bit, but as soon as the query is completed, the RAM will be cleared. Okay, so yeah, we have got the answer. You can see that the RAM has been cleaned up. Okay, so as the answer that you can see, the document appears to discuss evolution, role, and the societal perception of dogs. So it says that okay, it is about dogs. That's what it is. One small thing is about the sentence transformer. We have used the sentence transformer, this particular model. You can save the model, give it a name, sequence or model. So you first run the save model before you run this RAG. So once you run this particular save model.py, it will save uh, your the sentence transformer model into the sequence underscore model in this directory, and the same thing will be used in your sentence transformer, right? So when you're doing the embedding, it won't go to the server once again and pull in this model. It will take it from your local machine. That's it. Yeah, I think that's it for the video. If you have any questions, please to paste in the comment section. Yeah, thank you so much.